Section 3.1, Graphing. In this section we're going to talk about the two-dimensional coordinate plane, graphing basic equations, and also some two basic formulas that have to do with the coordinate plane. So let's get started. The first thing we're going to talk about is the two-dimensional, I'll just abbreviate 2D coordinate plane. So the 2D coordinate plane looks like this. You have a vertical axis, which is called the y-axis, and then you have the horizontal one, which is called the x, and the point where they intersect is called the origin. Okay. If you go to the right, the numbers are positive, just like on a number line. You can think of it as a number line. To the left, the numbers are negative. If you go up, the numbers are positive, and if you go down, the numbers are negative. So that's what a coordinate plane looks like. These axes, the x and the y axes, they split up the plane. You can think of the sheet of paper that I'm writing on, the black sheet of paper. They split that up into 4 regions. This is region 1, 2, 3, 4. And the regions are always named counterclockwise, and they're not called regions, they're actually called quadrants. So technically this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. Okay? Alright. So every point in a two-dimensional plane has to have two values. It has to have the horizontal value and the vertical value. So every point in 2 dimensions has 2 values. You always have the horizontal value first. So it's got the x value, the horizontal value, and the vertical value. The vertical value is given by the y value. So every point is written like this: x comma y. You always write the x value first and then the y. So let's just quickly plot a few points here. So here's a point. The horizontal value, if you go from here to here, the horizontal value is 2 and the vertical value is 1. So this point has coordinates 2, 1. We call those the coordinates of the point. Okay. Alright. Then let's do another one. Here's a point. If you horizontally, we go 1 unit. Vertically, we go down this time 3 units. So this point has coordinates -1 and 3. Now we don't always have to go up and down or sideways. We can just stay either horizontal or vertical. So let's take a look at those points. So here's a point. If I just go vertically up here, and that's it, I don't move horizontally at all. So horizontally I did not go anywhere, so my value is 0. Vertically my value is 2. Okay. And similarly you can draw other points in the plane. I could have this point, let's say the coordinates of this point are going to be, horizontally I'm going 4 units, vertically I go down 3 units. Okay. And then the last values, I could have something like this point. Horizontally we go -3 units, and vertically we don't go anywhere. So those are some examples of points. The main thing to look at is that each point is unique. Okay. Okay. The unique representation of each point. And if 2 points are the same, then the horizontal and the vertical values of those 2 points would always have to be the same because of the uniqueness. Alright. So those are points in the coordinate planes. Now before we go any further, let's take a look at 2 formulas that are associated with it. So let's say if I have a coordinate plane like this. Okay. And I have a point here. I'll call this point x1, y1, I'm calling the horizontal value x1, the vertical value y1, and I have another point here. I'll call this point x2, y2. The horizontal value is x2, the vertical value is y2. And if I connect them with a line, I want to find the distance of that line. I want to find how far it is from here to here. Now, I can't just subtract the value, x values and the y values and get that distance. That's not going to be the right answer. So I need to we need to have a special formula. So let's call this point P and this point Q. It's always good idea to label your points along with the coordinates. So the distance PQ, I'll write it this way, PQ. So this is the distance formula. This is a very useful formula. We use it quite a bit in applications when we're trying to solve some word problems or something, even when we work with circles and things like that. So it's a good formula to know. So the distance, I'll denote that with the lowercase d, distance PQ of the segment PQ, that's the distance of this line segment, is equal to the square root of the square of the x, the difference of the squares of the x values. So you take the difference of the x values and you square that, and then you add to that the difference of the y values. This formula is not that easy. It is easy to come up with because all it's using is you basically complete the triangle here and use the Pythagorean theorem to do that. If you're interested in it, you can let me know and I'll show you how to do that. But for now, the distance formula is just that. The difference, you take the difference of the x values and you square them. You take the difference of the y values and you square them. And then you take the square root of that sum. Okay? And then we have another formula called the midpoint formula. The midpoint formula basically gives you the middle of that line segment, the coordinates of the middle of that line segment. So let's say that this is the midpoint of this line segment. I'll call that R. I want to find the coordinates of that. So I want to know what are the coordinates of this point. What is the x value and what is the y value. Now the distance formula gives you a number. When you use this formula, you're going to get a number because it's going to give you the distance between those 2 points. The midpoint formula, like the formula tells you midpoint, it gives you a point back. Okay, so the midpoint of PQ, which we called as R, is going to be, you take the average of the x values. How do we find the average? We add the numbers and divide by the total number of items. So in this case, if I take average here, I take x1 plus x2. I'm adding 2 things. So we divide by 2 to find the average of the x value. And then to find the average of the y value, we add the y values, divide that by the number, which is 2. So there's your midpoint formula. So these are 2 formulas you should know. They're always associated with a coordinate plane with lines and so on. Okay. So let's take a look at just 2 examples really quick. Okay. Let's say I have a point P, which is 3 minus 2. And we have a point Q, which is 5, negative 5, negative 3. Well, let's make it a nice number. Also negative 3. So I want to find the distance and the midpoint. So we want to find the distance PQ and the midpoint PQ. Okay, so let's do that. So to find the distance, what do? We take the difference of the x values and we square them plus the difference of the y values and square them and take the square root of that. So it's a good idea to label these points. It'll help. Call this x1, y1. Call this x2, y2. Now that we have them labeled, let's do that. So what is distance PQ? You take the difference of the x values. So you take minus 5 minus 3 squared. Okay, plus you take the difference of the y values, which is, and I forgot to do something that I always tell you to do. When we have negative numbers, we always want to put parentheses around them, right? So let's do that properly. So you have minus 5, then we have minus 3 squared, plus we have minus 3 minus 2 squared. So I'm taking the difference of the x values, this value and this value, squaring that, plus the difference of this value and this value and squaring that. So let's just do a little bit of algebra here. Negative 5 minus 3 is negative 8 squared, plus over here we get negative 3 plus 2 squared, because the two negatives will become positive. So we end up with 64. Negative 8 squared is 64 plus negative 1 squared. So we end up with 64 plus 1, which is 65. So that's how you use the distance formula. It's just a matter of plugging a number into a formula and just working through the math. Okay. To find the midpoint, I'll just do that on the side here. So the midpoint of PQ, I'll call that R. So R is going to be, if you recall, the formula was what? You take the average of the x values, you add the x values, divide by 2, you add the y values, divide by 2. So let's do that. So the average of the x values, this is 3 plus minus 5 divided by 2, and we get negative 2 plus negative 3 divided by 2. So we get negative 2 divided by 2, and we get negative 5 divided by 2. And over here, negative 2 divided by 2 is minus 1. Always clean up your answers if you can, reduce them. So here's my midpoint, and here's my distance. Okay. So those are examples of the distance and the midpoint formula. We'll come across these formulas later in this chapter itself, and we'll be able to reuse them. But for now, just remember the two formulas. Always memorize formulas. It'll help you apply them much quickly and makes life a lot easier. Okay. The next thing we want to talk about in this section is equations of two variables. Actually, I'm sorry. Graphs of equations of two variables. Okay, so let's take a look at that. So first of all, let's define that. The graph of an equation of two variables, x and y, is the collection of all points x, y that satisfy the given equation. So the graph of an equation of two variables is basically a collection of all the points that live on that graph or that satisfy that equation. Okay, so here's an example. Let me just show you first. Let's say if I give you this, y is equal to minus x squared plus 4. This is an equation because it has an equality of two variables. Okay. Now, what does a graph of this look like? Well, all you have to do is find every point x and y. Every point has two values. Find every point x and y that satisfies this equation. That means that if I were to replace x and y with those values that I have, the two sides should be the same. Okay, so let me just go ahead and show you a couple of these examples so you can see those. Okay, so let's say that, let's start with a point, just a point I pick. So let's say I have minus 1 and 2. So x is minus 1 and y is 2. So let's see if it satisfies this equation. You replace y with 2 and x with minus 1, so you put parentheses squared plus 4. So you get 2 is equal to minus 1 plus 4, and you get 2 is equal to 3. Is 2 equal to 3? No. So that tells me that this point is not on the, so this implies the point minus 1, 2 is not on the graph of the equation y is equal to minus x squared plus 4. So this point doesn't belong on this graph, and we'll come back and address that in a second. Okay, so that's how you figure out which points belong on the graph and which points do not belong on the graph. How about this point? Let's take a different point. Let's take 1 and 3. Okay, so let's plug it in and see what happens. Y is 3. Okay, and x is 1. So we get 3 is equal. Remember, we're only squaring 1 here, not the negative. If we were, they would put parentheses like we did up here. Okay, so we get minus 1 plus 4. So we get 3 is equal to 3. So that's a good point. This point is on the graph. Okay, so it is on the graph. And there's many other points you can find. I just showed you 2 examples, and in a little bit we'll look at a whole bunch. Okay, so if the point is not on the graph, it won't satisfy the equation. If it is on the graph, it'll satisfy that equation. That means the two sides will be equal when you replace them. So now let's see how to graph it. So this is an equation in 2 variable. Let me show you how to graph an equation in 2 variable. And this time I'm actually not just going to call it graphing, I'm going to call it brute force graphing. Later on we'll learn some other ways to graph that are a little bit better than this. So what do we do? To graph a function of an equation in 2 variable. So to graph an equation, not a function, I'm sorry, an equation in 2 variables. Okay, randomly pick values of x and find the corresponding values of y to create a point xy on the graph. So that's how we graph by brute force. Okay, so let's take a look at it and go back to our example and see how to graph that equation. We had y is equal to minus x squared plus 4. So the thing we're going to do is we're going to randomly pick a whole bunch of values and create a table. So I'm going to randomly pick some x values, and sometimes depending on how the equation is given, you might have to pick a y value and then find the x value. Okay, so you might have to switch these around sometimes depending upon how the equation is presented to you. And then I'm going to plug it into this equation, and if I do that, I'm going to be able to find y, and once I find y, I have a point x and y that is on that graph. So let's do that up. And it's always a good idea to pick about a fairly good number of points to do this, because a lot of these equations are graphs of these equations are complicated. So if you only pick a few points, then it's going to be hard to graph them. I'm going to start by picking the first point that I'm picking some values. So I'll pick -2, -1, 0, 1, 2. I'm just randomly picking some x values. You don't have to pick these. I picked some negative, some positive, and I picked 0. It's always good to pick 0. Okay, so let's do this. So let's plug this in. So we get y is equal to minus of -2 squared plus 4. So I'm plugging this x into the value. So we end up with -2 squared is 4. So we get -4 plus 4, which is going to give me 0. So that tells me if x is -2, y is 0. I do the same thing for the next one. I have minus of minus 1 squared plus 4. So I end up with negative 1 squared is 1. So I get 1 plus 4, which is 3. So if x is minus 1, y is 3. Y is equal to 0. So we get minus 0 squared plus 4. So we just get 4. So we get 0 and 4. And when we pick 1, we get minus 1 squared plus 4. So we get negative 1 plus 4, which is 3. This is a point we did earlier. And then the last one is 2. We're squaring just the 2. Okay, so we get negative 4 plus 4, which is 0. So we get 2 and 0. Let me just do one more, 3. So we get y is equal to negative 3 squared plus 4. So we get minus 9 plus 4, which is equal to negative 5. So we get 3 and negative 5. So we got a good sample of points here. So now let's go ahead and graph this. Okay, so I'm going to draw my coordinate plane. And depending upon the biggest and the smallest value of x and y, we can scale it accordingly. So if you notice, the biggest value of x is 3 and the smallest value is negative 2. So it's a good idea to just scale by ones. On the other hand, if my biggest value was, let's say, 30 and my smallest value was 10, then I would scale by 5s. So I don't have to put down so many values on the x-axis. And this biggest value, I'm sorry, this should have been the biggest value for x is 4, I'm sorry, for y is 4 and it's minus 5. So this time I'll just scale by I'll scale by 2s just to be different. We have 4, 6, I have negative 2, negative 3, I'm sorry, negative 4, negative 6. And that's just, a scaling preference if you don't want to put down so many values on the y-axis. So my first point is negative 2, 0. X is negative 2, y is 0, so that's this point. My second point is minus 1, 3. So x is minus 1, y is 3, so that's this point. 3 is in here somewhere. Okay. My next point is 0, 4. X is 0, so you don't go anywhere horizontally, vertically, you go up to 4. The next point is 1, 3. So we have 1, 3. X is 1, y is 3. Then we have 2, 0. That's this point. And then the last one is 3, negative 5. So negative 5 is out here. This is 3, so it's over here. And it's always a good idea to label all the points. So this would be 3, negative 5. This would be 2, 0. This is 1, 3. This is 0, 4. Then we have minus 1, 3. And we have minus 2, 0. So those are my points. And then we just connect them. Obviously they're not in a line. You can see they're not in a straight line. They don't form a line, so you know it's going to be a curve. So you just have to draw a curve that passes through all of these points. Okay. So there's a graph of this function, this equation. Okay. So when you graph an equation of two variables, all you have to do is just randomly pick some x values, find the corresponding y values, and then plot them and connect them. Just a couple notes about this. Okay. Note. If the degree of the equation is anything, is any number other than 1. 1 means what? Linear, correct? When the degree is 1, any number other than 1, then the graph is a curve, else it is a line. So if the degree is 1 of the equation, then the graph will be a line. That's the only time you get a line, or else you'll get a curve like we just did. Okay. Now sometimes not everything that we graph will have two variables, so let's take a look at two special equation. Okay. There are two special equations that you should always know. The first one is this: when we have x is equal to a, where a is just some number. Okay, the first equation is x is equal to a, where a is just some number. Okay. Now this is not made up of two variables, we only have one variable. So what does a graph look like? Let's just pick some points and try to graph it. How do we pick? We pick some x. So if I pick So we pick some x, find the y, and we have a point. Correct? Now, in this case, I told you sometimes you have to switch it around and pick y and not x. In this case, they told you x is a. X is always a. So we have to pick some y values this time. So if x is a, y can be anything. So let's say y. I'm sorry. Let me do an actual example. Let's say y is something else. Let's say it's 1. So my point would be what? an 1. If x is a, y could be minus 5. So my point would be what? an minus 5. If x is a, y could be anything. It could be minus 2. So there'll be an negative 2. And let's do one more. If x is a, y can be 3. So we get an 3. So the point I'm trying to make here is, if they give you this equation where x is a, that tells you x is always a. It doesn't matter what y is. Y can be anything you want it to be. So you can see there's a set of points that satisfy this equation. X is always a. That's the only requirement for this. Y can be anything. So what do you think the graph of that looks like? If you were to graph this, so let's say this is a. This point on the x-coordinate is a. So let's graph this point. The first point is what? a1. That'll be this point, because if this is 1. The next point would be a minus 5. Okay, so we have, let's say this is minus 5, so that's this point. Then we have a minus 2, that's this point. Then we have a3, that's this point. So what do we know about this graph? What can you tell about this graph? All these points are in a line, you can see them. And that's because the degree is 1, so we expect it to be a line. So if you were to connect them, we just get a vertical line. Okay, so whenever they fix a value of x, they say x is a particular value, and that's the equation they give you, then the graph is always going to be a vertical line. So x is equal to a is a graph of a vertical line passing through the point a0, because it goes through this point. This point here is x coordinate is a, the y coordinate is 0. So it always goes through that point. So this is a special line. Okay, so x is equal to a is just a graph of a vertical line. Let's take a look at the other special line. I'm sure you've guessed it. It'll be y is equal to b. I'm not going to go through that much work like it did over here. You can do that. Out here on this equation, what are we saying? The y value is always b. That means x can be any random number you want it to be. And because the degree of y is 1 here, you know it's going to be a line. So this is the line. Y is equal to b is a horizontal line this time, passing through the point 0b. So let me go ahead and graph that. So here's my x and my y. So let's say this is some point B on the y-axis. So y is equal to b is just a horizontal line that goes through like this. And you can see if I pick any point on this line, let's say if I pick this point, if this is 1, 2, 3, what are the coordinates of this point? X is 1, y is b. If I pick this point, x is 3, y is b. On the other hand, if I pick this point, x is -4, y is b. So you can see the y values are always b, and that's what this tells you, y is always b. So that way we have a horizontal line. So these are two examples of special lines that you should always know. Okay? So that's how we work with graphs of two variables. All we have to do is basically to graph them, pick some random values of x and then graph the corresponding values of y, and then do the same thing. Then along the way we also learn two special formulas, so please make sure you guys know those. The last thing that we want to talk about in this section are two new is a concept called intercepts. Okay, intercepts are where the points. Intercepts are points, again plural, where the graph crosses or touches the x and the y axes. Okay, the key thing is they're points, always remember that, and where they touch across the x and the y axes. Before I show you how to find them, let's take a look at some examples of intercepts. Okay, so let's say if I have a graph like this. So let's say this point here is 1 and -3. So this is 1, 2. At this point here is 3 and 0. And this point here is -2 and 0. This point here is let's do this. Call this -1 and 2.5 negative. Ugh, doing it wrong. 1 and -2.5. So this is 0 and -2. So what are my x-intercepts? I'll abbreviate that. XINT stands for x-intercept. Where does the graph cross or touch the x-axis? Well, it crosses the x-axis here because that's my x-axis. Okay, so my x-intercepts are here and here. That's where it crosses the x-axis. So I have two x-intercepts, -2 and 0 and 3 and 0. Okay, they're points, so make sure you write it as points. What is my y-intercept? Y-intercept is where it crosses or touches the y-axis, so in this case it's this point. So the y-intercept is 0, 0 and -2. So that's how we get x and the y-intercepts. Let's do one more example. So let's say if I have a graph like this. So let's say this point here is -3, 0. This point here is 0, 4. And this point here is 2, 0. Okay, so what is my x-intercept for this graph? Where does it cross the x-axis or touch? In this case it touches the x-axis here at -3, 0 and crosses at 2, 0. So those are my two x-intercepts. And my y-intercepts are what? They are 0 and 4. That's how you find x. That's how you figure out x and the y-intercepts from a graph. But how do you find them if you were given given an equation? What do you notice about both of these examples? Let's just pay attention to the x-intercepts for a second. I have two x-intercepts here. What do you notice of every single x-intercept? Remember, x-intercept is a point, right? So what do you notice about every single one of those points? What's special about them? The y value is always 0. So that gives you an idea on how to find the x-intercept. If you're given an equation and you want to find the x-intercept, all you have to do is set y to 0. Similarly, if you notice what's special about the y-intercept, if you look at the two y-intercepts, the special thing is the x is always 0, because if it crosses the y-axis, the x value at that point will always be 0. So let's write that down and then take a look at a couple examples on how to find the x and the y-intercepts. Okay, to find the x-intercept, we set y to 0, and to find the y-intercept, we set x to 0. So these are the two ways we can find the x and the y intercepts. And this is very important. We're going to be doing a lot of graphing in this section, in this class. So it's very important that you know these things, because when we graph, finding x and the y intercepts is one of the best ways to find a couple points on the graph very quickly. So let's take a look at how to do that. So let's say I want to find the x and y intercepts of the following equation, of the following graphs of two variables. So here's the first example. Let's say if I have 2x plus 3y is equal to 6. Let's make it 2x minus 3y is equal to 6. Now, before I do this, this is an equation of two variables, so I know I can graph this in two dimensions. If you notice here, the degree of x and y are 1, so you know it's going to be a line. Okay, just for your own benefit, this is. So how do I graph this? How do I find the x and the y-intercept? To find the x-intercept, we need to set y to 0. So we take y and set that to 0 in this equation. So let's do that. So we get 2x minus 3 times 0 is equal to 6. So we get 2x is equal to 6. So we get x is equal to 3 when you divide by 2. So the x-intercept is 3 and 0. Make sure you write it as a point. X is 3, y is 0. Okay. Now to find the y-intercept, what do? We do the same thing, except we set x to 0. So in this equation we get 2 times 0 minus 3y is equal to 6. So we get negative 3y is equal to 6. Divide both sides by negative 3, so y is equal to negative 2. So now we get the y-intercept, x is 0 and the y-intercept is negative 2. Okay. Let's take a look at one more example. Let's say if I have y is equal to x squared minus, let's make it a little bit more complicated. Okay, let's take x cubed minus 36x. Okay, so let's do this. Let's find the x-intercept. How do we find the x-intercept? We set y to 0. So we get 0 is equal to x cubed minus 36x. So how do we solve this? This is degree 3. We really haven't talked about solving degree 3 equations, but that's not a big deal. Anytime you're solving equations, it's always good to look for the greatest common factor anyway. So let's do that. So we get x is common, so we get x squared minus 36. Okay. Now we need to factor this, so we can just do that on the side here. Okay, we have x squared and then you have 6 squared. We go using difference of two squares formula, because anytime you're factoring, two terms, we want to use one of those formulas that we talked about in chapter 1. So in this case 6 can be written as a square, so I can write it as x minus 6 and x plus 6. So let's do that. 0 is equal to x times x minus 6 and x plus 6. So we know that this product here is 0. What does that tell me? One of these quantities has to be 0 using the product theorem. So we get x is equal to 0 from this one. Then we get x minus 6 is 0. Then we get x plus 6 is 0. This is already done. This tells me x is equal to 6. This tells me x is equal to minus 6. So what are my x-intercepts? I got three values of x when y is 0. So I have three x-intercepts. The first one is x is 0, y is 0. The second one is x is 6, y is 0. And the third one is x is minus 6, y is 0. So I had three x-intercepts for this problem. Okay, so you can get multiple x-intercepts. So you just have to make sure that you follow the game plan on how to find the x-intercept. That is basically setting y to 0. If you have any equation that is degree 3 or higher, always remember the only way you can solve it is by factoring. And you know how to factor, right? You look for the greatest common factor and so on. Okay. Now that we found the x-intercept, we have to find the y-intercept. So let's do that. To find the y-intercept, what do? We set x to 0. So in the previous problem, if we set x to 0, these are my x values here. So we get y is equal to 0 cubed minus 36 times 0. So you just get 0. So in this case, my y-intercept is x is 0 and y is also 0. Okay. So that's how you find x and the y intercepts of a problem. So make sure you practice a few problems on learning how to do that, because they do give you a couple points on the graphs that you can graph very quickly. Okay, so take advantage of that, because now if we were to graph this equation, remember how do we graph? We randomly pick some values of x and do it, right, and find the y values and find points. We can still do that, but we also know these 3 points are on the graph. Okay, so we have 3 points already. We can find a few more points using brute force, and then we'll have a pretty good picture of what that graph looks like. Okay.